Welcome everybody to the September webinar. Thank you very much for joining us today. As I mentioned, we're on an integrated audio bridge, so you should be able to get the audio feed through your computer. The webinar is going to be recorded, and obviously the Q&A sessions as well, as you've had with previous webinars. So that's all going to be made available, including all the transcripts, all the Q&A session questions, after the show. We will try to answer as many of your Q&A questions as we can throughout the time. If we are not able to do so, we will try and follow up, make sure we get those answers and get those back out to everybody. We have a panel team, many members of the VIRL development and support team already on the call today, so do please post your questions. Okay, so as I mentioned, up and available with all the Q&A questions, you should have the ability to post your questions there. And then hit send, and we will be posting all the material, as you can see, on the community website, the link there on the screen right now. Right, so what are we going to be covering today? So we have a couple of different pieces and then a sneak peek of a new feature that's coming up. We're going to be starting off today, so our colleague Alejandro is going to be walking through connectivity, external connectivity, looking at how you can use VIRL servers hooked up to physical equipment, and he's got a pretty detailed walkthrough as to a number of different options and ways in which we can get connectivity. So if you're thinking about using VIRL in conjunction with physical equipment, whether that's network equipment or hosts, Alejandro is going to show us how that can be done. We're also joined by Matt Anderson. Matt's a Cisco engineer, but he's put together some really interesting stuff to do with mini servers, and Matt's going to be doing a view as to how you can put VIRL onto a mini server and the kinds of things that he's been able to do with this. So we'll be joined by Matt a little bit later. Then we're going to be covering a new feature. So Dan Borg, who's one of our development engineers who works on the VM Maestro side of things, is going to be showing a new feature, this thing called Simulation Viewer. And then we're going to be rounding out with questions and answers. Okay, so as I said, please keep the questions coming throughout the session. We will do our best to try and answer them as we go through. And with that, we're going to hand over to Alejandro, who's going to take us through our first topic, so looking at external connectivity. Over to you, Alejandro.
All right, thank you, Joel. All right, everybody, let's get started. This is a pretty fun piece for me. Actually, I really enjoy creating the external connectivity because, from my perspective, I kind of feel that that's really when we get to, well, we really can use VIRL to its fullest extent. Just bear with me one moment. Let me get my shares here ready. All right. All right. So let's start diving in. So hopefully everybody can see this. We should be seeing our first page one of our video. All right. So again, today we have an objective. Our objective is not only to get external connectivity, but also have two separate sites, be in two separate simulations, talk to each other, and also from one side be able to get a web server from running on the other side. So what that means is this: we're going to have RTP be in simulation 1 and San Jose be in simulation 2. Server 1 on RTP side, we're going to install Apache Web Services. So server 2 on San Jose can come across our flat connector and access that web page. Now the cool thing or rather how we're going to do this. How we're going to do this is by using our flat connectors. The flat connector is our way to connect the virtualized nodes out into our physical environment. It is attached. That is really our gateway out, and also our gateway into the simulated node. And this is what makes VIRL pretty cool. So what are the flat connectors, and how do we use them? So let's go ahead and start with a quick little presentation. Try to first figure out what are some of the NICs that we configure in VIRL, and what are the flat connectors. So if you remember, when you initially installed VIRL, you had to create, and also you have to configure some of the NICs. We have our management, which is pretty self-explanatory. We need that for connectivity to our VIRL VM. And then we have our flat and flat 1. Those are the two that we're going to focus on are really just flat and flat 1. We're not going to talk about the other network interfaces as for our conversation they're not necessary. So again, flat and flat 1. Oh, if I can advance. All right. So the flat connector is our subnet of 172.16.1.0. Flat 1 is going to be a subnet of 172.16.2.0, and those are our default. Even though this presentation is going to focus around ESX server, just note that we can still create the same type of connectivity when you run VIRL on a Mac or PC using Workstation or VMware Fusion. In ESX, we create port groups named flat and flat 1. In the PC side of things, you'll have a VMnet, VMnet 2, and VMnet 3. So how does that all come into play? Well, first let's looking at how we use the flat connector. The flat connector, as we saw originally, is our gateway out. Is the little in between the virtualized and the physical. We can very easily have a single node within our simulation connect directly out into our physical world by just bringing in our simulated node, in this case an IOSV, and then attaching our flat cloud to it. As soon as you do that, we have direct connectivity from the outside, as long as actually I should say that the 172.16.1.0 network will be configured within VIRL. However, because it does need to be available externally, that also needs to be a valid network externally, being on your physical devices. Once you have that connectivity, you can now point your terminal, being PuTTY or being iTerm if you're on Mac, to 172.16.1.236, as we see here, in Telnet or SSH, and begin to work with that node directly. Now, by default, when we create our topologies, our management network is set as not specified. When this happens, we create an OpenStack router internally with a network of 10.255.0. So that's what happens all the time, and that's how we can connect to all the other nodes. Also note that in this particular case, only this node will be the one that's available on our flat, because we have not connected the flat cloud to any other node. So there has to be a better way to do this instead of creating a flat cloud for each individual device in your topology. Well, there is a better way to do this, and that's what we're going to do. We're going to create an out-of-band access using the flat. Then we're going to use our other network, flat 1, for data. And flat 1 is how we're going to connect site 1 and site 2. The changes that we need to make are, when we create our topology, in the topology properties, you're going to change our management network to a shared flat network. When we do that, we now get rid of the OpenStack router and automatically use our flat 1 out-of-band management network. Now, because you're now able to directly connect out into your physical environment, this could arguably pose a security problem. That's something that you would have to take on a case-by-case basis and depending on your own individual environment. So let's take a look at what this will end up looking like once we're all said and done. Again, our goal is to connect server 2 to server 1's web services. They're both two separate simulations running within VM Maestro. One of them is the default, which he creates his own OpenStack routing or out-of-band management. The other is going to use the flat 1 out-of-band management. But both are going to share our flat 1, being the 172.16.2.0 network. That is our common link, and that is how we're going to connect from one end to the other. All right, so let's go see what this looks like when we look at it from the Visio perspective. Yep, let me kill that. All right. So now we should be seeing our Visio diagram showing our ESX host. Okay. So we have our ESX host running our VIRL VM. The VIRL VM has its 5 interfaces. Again, we're only going to focus on ETH1 and ETH2, that being flat and flat 1. Now, these 2 interfaces are they're also going to carry a VLAN because they're separate networks. Since I'm going out a single link into my physical switch, we need to associate those networks to a VLAN. So I said VLAN 10 and VLAN 20. Those are our 2 networks that we're going to be dealing with going out. All right. So let's go ahead and let's take a look at VM Maestro. We'll start out from this perspective. Okay. So I hope everything's refreshing as expected, and we should be now seeing VM Maestro and looking at it from the design perspective. So again, here I created my 2 topologies. We have RTP and San Jose. They're both 2 identical topologies. Note that we have VLAN 20 as our flat 1 cloud on both sides. That is our common link between the 2 sites. Here we have our shared flat. So remember, since we're doing our shared flat, that we don't see that shown here. It's in the background. We will be able to see it once we start our simulation and we start looking at those IP addresses. Okay, so let's start taking a look at our IP addresses. Let's go over to our simulation, and let's go ahead and connect to both of these nodes right here. The telnet to both of those. Let's drag this over so we can all see it. Again, log into our iOS device and our server. Okay. So let's see what our server has so far. We have our simulation up and running. Let's take a look at netstat. All right. And we see that he already has a gateway of 1.2. 1.2 is the gateway for flat, and that's our way out. Since he has a gateway, can I ping directly to, well, let's see if we can ping Google. Okay. Yep, we can ping it because we're going straight out of his management interface, being ETH0. He has a default gateway. Again, we don't see ETH0 here because that is in the background. That is for management. So we're able to get out there with no issues. So let's just run sconfig to figure out our IP addresses that we have so far. There's our ETH0 for management, and here is our IP address that we need to know, 10.0.0.1, because that's how we're going to, our server 2 is going to connect and how he needs to find them. All right, so let's go take a look at server 2. Let's see what these guys have going on. Let's drag this over here. Let's log into our iOS and our server 2. Okay, so the same thing. Let's just take a look at his IP address. Here we have our San Jose subnet, which is 9090.0. And here we have his out-of-band management on E0, 10255. So if we look at netstat -nr, we see that by default, when we run out of netkit, it's going to give us our 10255 network as the gateway beyond E0. So, which is probably not what we want, because if we try to ping, say, google.com, we'll notice that we're not going to get a response. We're not going to get out that way, because that network is not connected to the physical side, and it's not connected to the outside. Okay. So, let's take a look at ESX views for a brief moment and understand some of our networks and our VLAN IDs. We have flat, we have VLAN ID of 10. On a flat 1, we have a VLAN ID of 20. Okay. Again, we do expect that you have some understanding of routing, basic routing, just going for like point-to-point routes, not like having to know routing protocols, but just point-to-point routes, and also understanding what a VLAN is and what it does. Simply put, a VLAN is nothing more than just another network. Now, in our vSwitch, we do have to configure our port groups to allow promiscuous mode. So we'll do that for flat and for flat 1. Okay, so let's go back here. So next, let's try to get this connected. All right, from server 2, we need to be able to get to our 10.0 network, which at this point we cannot. If we ping 10.0.0.1, that's going to fail. So let's start working with our connectivity listed here. All right, so for us to actually make the next hop, we need to get our server heading in the right direction. So we can go ahead and say sudo, whoops. Let's go here. Actually, I'm sorry, let's go back to server 1. Okay, so I need to get to my 9090 network from server 1, which right now I don't have that network here. So we'll say sudo route add network 90.0.0/16 and gateway being 10.0.0.2. .2 is our iOS device. Show IP interface brief. And there he is. So that's going to be his next hop. So we don't get sent out to flat. All right. So now we can get out and find the 9090 network. But server 2, he's not going to be able to get to our 10 network because he's going to be sent out this way. So we'll change that and we'll say sudo route add net 10.0.0.0/16 gateway. Our next hop, which being that's our link here, so it's going to be our 90.2. 90.0.2. Okay, so now let's see if we can ping. Okay, and now we're pinging. All right, so now we have connectivity from one side to the other. Let's go over to our server 1, and let's get our website in place. So sudo apt-get update first. So remember that our default route is going out flat. So we have that connectivity. And this should take a second to complete. Okay. So now we can go ahead and just do sudo apt-get install, say yes, Apache 2. All right. So let that go ahead and complete. That should go pretty fast, actually. All right. So from server 2, we can ping it. So once this guy gets his, yep, there we go. Web server now it's already installed and it's up and running. So let's see if we can get it from server 2. HTTP, so we can just do curl, the IP address, 0.1, and there's our web page. But is that for real? So let's see what happens if we disable that interface. And then let's just do a ping. Can't get there. So let's just enable it. So make sure that I'm not lying to you. And there we go. Now we're back to connectivity. So now we've achieved our goal of having our site 1 have a web server available for site 2. So server 2 can now reach site 1, get the web page, and is happy-go-lucky. So what about us from the outside? So from the outside, we're on 1.83. If I open up my browser, let's open up a new window. Let's say 172, whoops, 172.16.1. Let's see, 83. And there's our web page. As far as managing our nodes, so here I have a server, and he is running on the 1.0 network, the 172.16.1.0. Okay, so there's his 121 or 1.20. So now we're able to go here and say telnet 172.16.1. Go back to our simulation and take a look at iOS device, and he is management on 1.80. And there we have it. Log in. And now we have connectivity externally. And as long as you have nodes on the 1.0 network, or on the same network as your out-of-band, being in our case the flat network, then you can access and manage all your nodes as you would a physical node using whatever terminal that you prefer, being iTerm, PuTTY, etc. And that kind of wraps it up.
All right, thank you very much, Alejandro. I'm going to take the ball back. So a couple of people were asking, will this material be posted? Can I get hold of this material afterwards? Yes, absolutely. So the material is going to be posted on the usual location. So we'll have material that's up on the community website. And we'll also be posting material on our GitHub repos, so the topologies will be there for people to pull back. Okay, let's just I need to stop the sharing.
Give me one moment.
And pass the ball. All right, great.
All right,
okay, thank you.
Back.
Thank you very much. Okay, so in a moment, Matt is going to take over. So Matt Anderson, as I mentioned, Matt is a colleague here at Cisco. Matt's done some interesting things, putting VIRL on a mini server. Some of you may already have mini servers. Some of you may not have come across these things. So it's got some interesting stuff to share with you, may spark some ideas. Matt, take it away.
Thanks, Joel. Yeah, so my name is Matt Anderson, and I see that I just got the presenter ball, so give me a moment to share my slides. Okay, so I'm going to focus on one particular type of mini server called an Intel NUC, or Next Unit of Computing. The picture you see here is the case that I got for mine that I use, and I'll kind of show you why I did it and how I built it and what I use it for. So to start, why? A big aspect here is portability. You know, even dealing with a laptop that could be dedicated to VIRL. A laptop is a fairly large thing to carry around. It has things you don't need, like a monitor and keyboard, when you're actually using it. So it's not really optimal. The NUC, which you can see inside this orange case in the middle, it fits in a case that's really only about 9 inches wide at the interior, and the total setup weighs less than a few pounds. The other reason why is dedicated hardware. Prior to this, when I was using VIRL outside of the office, I was usually running it in VMware Fusion on my Mac. And while the Mac has specifications that can easily run VIRL, you can't do too much else with it while it's running, so it's a shared resource. Another you know, kind of thing that had me questioning whether the NUC was right for this was it can't really do more than 16 gigabytes of RAM. Now, there is a way that you can get up to 32 and soon beyond that by using sort of proprietary SODIMMs from a company called Intelligent Memory. But because they're the only ones selling them, it's fairly expensive, and you're looking at about $700 just for the RAM for that much memory. But you know, most small system chipsets, even in laptops, have the same 16 gig limitation, so there aren't a whole lot of better options out there. Another reason for this was external connectivity. So I wanted to make sure that I could provide all of the FLAT1, SNAT, and any other external interfaces from VIRL, and I've done that with a mini patch panel. And then there's a small Wi-Fi access point for shared access and the ability to connect to the environment without wires. So a NUC is they call it the next unit of computing. They basically have a soldered-on CPU, i3, i5, i7, kind of a laptop-class CPU, but with a kind of a desktop capabilities in terms of GPU and Wi-Fi, Bluetooth, and USB connectivity. It takes laptop RAM. It can have either a laptop hard drive or the smaller M2 SSDs. And actually, so this is a mistype here. It's 4 USB ports. One built-in GigE, an HDMI out, and a mini DisplayPort out. So it can be mounted to the back of a monitor as well, which is kind of why they call it the next unit of computing. But it's really just a DIY kind of all-in-one setup. So to give you an idea of how big it is, this is my iPhone 6 on top of it. It's very thin if you use an M2 SSD form factor. The case is a little bit thicker if you opt for the one that can take any 2.5-inch hard drive. So the bill of materials for mine, from the bare bones system to the RAM, the hard drive, USB hubs, and GigE adapters, is under about $600. So really not too bad if you compare it to, say, buying a laptop to run VIRL. And you can add to that the case and some of these other things, which are not really mandatory. And before I got these, I put everything in a laptop bag and was able to carry it around with me pretty well. So this is the layout I have on mine. There are the 4 USB ports that are built into the NUC, this blue box on the left side. And to get all of the VIRL external interfaces, I have a 3-port USB hub that happens to have a built-in 1 GigE port, and then I've added 3 additional GigE adapters on USB 3. connected those to a patch panel, and that makes it easy to plug cables into it without breaking things. The Wi-Fi access point is very compact. It takes USB bus power, so it doesn't need its own AC brick. So really this whole setup just needs one wall connection for power. I've used this kind of extensively, in the course of doing business over the past the past year for this setup that I built. At the IETF meeting in Dallas this spring, I used this as part of a larger demo lab, and you can see the monitor that I used for this just below the larger TV screen. The NUC is actually hiding behind this TV, you can't see it. But it provided a nice way of adding virtual routers to topology to get additional sort of lab size out of a portable demo setup. I've also used this for customer tutorials and demos, taking it on the road with me. The basic alternative to doing that is to run VIRL in a cloud somewhere. And while we also have that option, this is kind of a nice way to get hands-on and to see how it works. And the same goes for learning. Being able to connect people who don't work at Cisco into the same cloud is a little bit difficult. So instead, putting this on the table or on the conference room desk, they can connect to the Wi-Fi, and we can walk through the setup in VIRL and what we're showing there. And generally speaking, questions about how routing protocols work or what packets look like on the wire or anything along those lines, this is a nice fast way to get those answers. So how do you do this? Well, this is the bare metal ISO that's available when you purchase VIRL. And there is a guide for this at the link on the fourth bullet. But before you can use it in a system that doesn't have a CD or DVD drive, you have to format it and write it to a USB stick. It's the same procedure you would use to put Ubuntu on a bootable USB. And so you can see the link there and see kind of how that works. You do have to enable USB boot and make sure that the priority is high on the NUC, and I'll show that on the next slide. And after the setup is complete, there's some things that you can do to make sure you know what ports are which. So first, when you boot up the NUC, there's the UEFI or Visual BIOS that you can press F2 to get into. There's a boot order table on the left and a legacy tab that you can select. And then the USB drive, which I've highlighted here, by default is not at the top, so you can move that up to the top. You can see the second boot device is my M2 SATA hard drive and then LAN. You hit F10 to save, exit, and the system will reboot, and it should boot off the USB. So for those of you who have done the bare metal ISO installation in the past, again, you can follow the instructions at this link. What it will do is it will boot a live Linux OS, and there's a shortcut on the desktop of that OS to install to the hard drive locally to make it permanent. And then from there, you can follow other setup steps to install your salt keys and whatever else you need to use to run VIRL. The last step that I found was very helpful because I had some annoying problems with Ethernet interface names changing was to make sure that the persistent net rules that map device MAC address to Unix interface name are what you expect them to be. There's a default setup here, but what I found was if you have the hub plugged into a different USB port, or if for whatever reason you moved adapters around on that USB hub, ETH1 may have become ETH3, and etc. And so doing this makes it nice and static, and you don't have to worry about that happening. So that's about all I had. I'll open it up for questions.
All right, thank you very much, Matt. A quick question, there's a few that come straight to mind. What you've just described, is this specific to NUC, or are there other mini server devices that are out there?
Yeah, of course, you could do this with other mini servers. It pretty much applies to any quote-unquote bare metal ISO installations of VIRL. I've done this on smaller Cisco UCS servers, in other words, servers that have around 48 gigs of RAM instead of half a terabyte. And those wouldn't have USB Ethernet adapters, so that's one thing that makes NUC a little bit different. Yeah, I mean, really, there's nothing inherently special about using NUC for this, but it's just to point out that even a very small form factor, small amount of memory mini server can be useful for VIRL. Now, one of the things that you'll notice is that with only 16 gigabytes of RAM, you won't be able to start very large simulations, but even running larger footprint operating systems like XRV, I can run up to about 5 nodes of XRV, and if you're able to tune the quotas differently to basically tax the system more heavily, you may be able to run more than that. Running IOSV, which is a lower footprint, I can run a dozen or more in a simulation, and no issues. And with the SSD, which again I highly recommend versus a spinning hard drive in any microserver, the simulations start very, very quickly.
Okay, that was actually a question I was about to ask you. What kind of performance do you see? Okay, yep.
Yeah, so it's great performance. It's better than on my MacBook Pro laptop, which has a similar number of cores and memory.
Are there any things you would say, sort of, words of advice for people if they're thinking about going out there? As you mentioned, there's like i3, i5, i7. Is it just a case of, the more money you can throw at it, the better, or are there sort of other considerations that people should be thinking about?
Yeah, that's a great question. So when I was shopping for this, I was looking at the i3 versus the i5, and there's a big enough price difference between them that I went ahead and got the i3 because both of them are dual core, both of them can do 4x hyperthreading, and the single core performance of the i3 on paper is not that much reduced. I think the i5 may have a faster GPU, and it may have a little bit more cache, but in my experience, the i3 is sufficient for running VIRL.
Okay.
Of course, if you have the extra $50 to $70 to spend on the i5 and you want something that may be a little bit more future-proof, you could always do that. None of the NUCs that I've seen have a low-cost, actual, true quad-core option. They're all dual-core 4x hyperthreading, and that seems to work fairly well for VIRL anyway.
Okay. I mean, one of the things that you've shown here is actually using the bare metal installation, effectively taking the ISO, converting it into a USB bootable stick, and bringing that across. Do you know, what about things like ESXi? Could you put ESXi onto a NUC and run virtual machines directly on there if you wanted to?
Yeah, so besides the fact that there's not really enough system resource to share between multiple VMs running under a hypervisor like ESXi, say you wanted to use ESXi for the convenience of running vSphere, vCenter, and all the admin tools, you could do that. I haven't tried it, but I'm concerned that the system itself using generic USB Ethernet adapters and probably hardware that VMware hasn't certified with ESXi, you could run into issues there. It's probably not insurmountable, but it's probably not going to work out of the box with hypervisor.
There'll be a wiki page somewhere.
There will be a wiki page somewhere for that, whoever wants to try that first, yes.
Great. Okay. Matt, thank you very much for your time. Really appreciate it.
Thank you very much.
All right. Let me try and steal the ball back from you. Okay. All right. So thank you very much, Matt, once more. Okay. And we're going to finish up. Well, we've got Q&A at the end, but we're going to finish up this section with my colleague Dan, who's going to show us some new features, new functionality that's going to be coming to you very, very soon. Dan, all yours.
Thank you, Joel. I'm just going to go ahead and share the entire desktop for simplicity. You ought to be able to see VM Maestro. So I'm going to be presenting a couple of new upcoming features for VM Maestro, and I'll probably sidestep and point out a couple of other additions here. So first of all, one of the major improvements we've done is we've bundled the JRE as part of VM Maestro, so you ought not have any Java-related installation issues anymore. It should be all completely self-contained. Another benefit is in the projects view, when you hover your mouse over any .virl file, you'll get a graphical preview of the contents of that file, which is particularly useful when you are doing remote imports of .virl files from perhaps a Git repository. Go ahead and open this one. This is an older version of a sample topology that came with it. Just wanted to point out There is one node here that is currently set to be excluded from the simulation launch. By the way, I am speaking rather quickly because I realize we barely have enough time here, so if I am speaking too quickly, please just let me know. I'll slow down, but for the sake of the demo, I'm going quickly. Yeah, so take note that this one node is currently set to be excluded from the launch. And because of that, it has a little decorator on its top right corner and a tooltip showing you that it's excluded from the launch. The only other change I made was that I've added 3 connections from server 1 to PE2. So you can now, in the toolbar, you have a Show Topology Labels control here that allows you to expose various elements of your topology. One of the more popular ones we think is going to be the interface names. This allows you to visualize all of the interface names of each connection endpoints, as well as the loopback IPv4. And because of this, as you can see, it quickly becomes quite busy. So you may need to lay out some of your topologies to make better use of the real estate. But anyway, I'll hide the IPv4 for the sake of this demo and go ahead and launch. So for the launch itself, pardon me, for the launch itself, you can still just hit the topmost launch button, but you now also have the ability to specify other launch options, such as by default, you only could ever launch a simulation with a system-generated simulation ID. You now have the ability to specify your own if you wish, and specify what the backend ought to do if that sim ID already exists. So for the sake of the demo, I'll just pick the same existing one, except that I'm going to exclude the project name and relative path to make it a little bit easier. You still have the ability to specify a simulation expiration. Switch to the simulation view. Simulation view is largely the same as before. The difference is that now you get a little label decoration on each node showing you the current simulation state, as well as well, you always had the simulation state textual orientation, but now you have it graphical as well. And that graphical orientation is also represented on the new simulation viewer. The simulation viewer is effectively an instance view of each simulation. So if I were to go back to the original VIRL file and launch a second concurrently running simulation of the same topology, you would get a second and third and fourth tab, each one of which is specific to the simulation it's bound to. So this effectively allows you to interact with your topology in the way that you had to do via the simulations view in the past. So once again, PE4, I'll remind you, was set not to launch. And currently we're waiting for all the nodes to come up. You can largely also control what is being rendered on this topology. And even before it's fully up, I can start interacting with it. So for example, as you saw in Alejandro's demo, he can go to any endpoint of a given connection and interact with the interface on either endpoints by just right-clicking. You have to right-click on the RJ45 connector, and it brings up the context menu, so you can, as he did, disable an interface or create a packet capture or traffic capture on, let's say, this interface here. I'm going to go and create one, accept the defaults, but as you can see, you can specify your own PCAP filter and various limits. Actually, let me set the time limit of 10 seconds. And go ahead. So now you see a little decoration on it showing you there's a packet capture happening on here. You can interact with it and start, even before it's terminated, you can even start downloading the intermediate contents of the packet capture if you wish. You can also manage all of the current running packet captures in new packet captures view. So they will all be listed here regardless which simulation they're currently running in. And again, you get the same capabilities of downloading them. Once it's completed, the little green LED will turn white, I believe, indicating it's ready to be completely downloaded. You can also interact with the various nodes. Everything you used to be able to do via the simulations view, so when you right-click and you take a VM image snapshot of a server, for example, or Telnet connector, all that stuff is now doable directly on the nodes themselves in a context menu. And that is about it. Oh, yes, also for the global jump host and simulation-specific LXCs, we are exposing those accessors via what we're calling the breadcrumb viewer on each instance of the simulation views, or the simulation viewers. So you can just click on the chevron here and get the same accessors as you had on your management LXC node in the roster view, or the simulations view. I went very quickly, but I hope I covered everything. So let me show you. If I now downloaded this now completed PCAP file, you can pick where to download it for. By default, it will create and open a new project in your workspace called My Captures. And if you have an application already installed on your system capable of opening those PCAP files, it will open it for you. The first time you open it, or first time you download it, it will prompt you whether you want to, but effectively I have Wireshark installed, so it opens it up there. Any questions? Otherwise, I think that was it for me.
Thank you, Dan. So just to clarify, although it might be a little confusing, it says Cisco Modeling Labs at the top of the bar there. What you are looking at is actually VIRL. Dan's one of the developers. He's using a developer environment here, and it says Cisco Modeling Labs at the top. So sorry if that's confused a few people. This is stuff that's going to be coming in VIRL and will be available for people soon. So yes, another question. Why not using native Wireshark but X11? So Wireshark is not a native application, at least not on the Mac. You've got to use X11 or Quartz in order to support it. So that's what the Wireshark application comes up and is using there.
I should also point out that VM Maestro doesn't care what packet capture viewer is installed on your system. Whatever is capable of handling .pcap files will be used by VM Maestro.
Excellent. All right. Great. So we have come to the end of the various demos. So Dan, if you just want to stop the sharing. Thank you. Okay, so number of people have been asking all sorts of questions. Tom, Valerie, are there particular questions that are worth highlighting and just covering for people that we haven't been able to get through? Anything that's been lots of questions about?
I think that you actually, there were a lot about there were several about the NUC, but I think that you guys answered all those already.
All right. There was one other that I saw going past. There were people asking about what the performance is of some of the bigger virtual machine images, so things like the CSR 1000V, iOS XRV. Matt, are you still on? No, I think Matt's dropped off. Okay, I mean, certainly on the NUCs, I think, Ralph, you might be able to answer what kind of performance you've been able to see with something like those bigger footprint virtual machines running on the NUC.
So I was having quite good experiences with the NUC. So I was telling in the question and answer session that I was able to run up to 15 nodes, maybe even sometimes more iOS V nodes in that environment with 16 gigabytes of RAM. So I have to say that I'm using an i7 CPU, so that is certainly a difference there. It doesn't have more cores or something, so it's still limited to 4 virtual CPUs, but the performance of that thing is really screaming.
Great. Okay, thank you. Some other questions. One of the guys asking about new features in running viral simulations without going through VM Maestro. So you may have seen back in the August release that we were having capabilities, so the packet capture capabilities that Dan just showed, the link, the interface up capabilities, those are all there in the live visualization capability, which you can access through the User Workspace Manager, the UWM. So that functionality is directly accessible through the web interface. So if anything, this is bringing VM Maestro up into parity. Other question, when is this new version of VIRL Maestro going to be coming out? So it's in beta right now. We have some people who are testing it out and hopefully finding that there are no bugs. Hopefully. Dan, there are no bugs, are there? I hope. Anyway, so this will be made available fairly soon. And so we really want to get through, make sure that the beta program goes well. One thing to note, this version of VIRL Maestro will be compatible with the current version of VIRL that's out there. So if you've got the August release, you'll be able to take this version of VIRL Maestro, run it against a VIRL server, and you'll be able to use that without having to do any sort of VIRL server upgrades. So that will also be there. Okay. With that, I'm going to round it out. I'm just going to thank all our presenters, Alejandro for doing the external connectivity piece. Thank you very much. Matt Anderson, although he's dropped off, covering the session on the Intel NUC and mini servers. And Dan, thank you very much for the demo today of the new VIRL Maestro. Thank you all to my colleagues who have been helping on the panel questions today. As I said, we will do our best to go through all of the questions that we've not been able to answer. Get those answers written up, get those available. And as usual, with all the webinars, the recordings, the transcripts will be available on the community website. And we look forward to seeing you when we do our October webinar. Thank you all very much, and we're going to close out now.